Welcome to this, the second episode in our 5-part series on exploring quantum computing and quantum programming. In this episode, we're going to look at a logic puzzle that we're going to solve with our quantum computer. And as we take a look at this puzzle, we'll see that it's a fairly simple puzzle and doesn't need a quantum computer, indeed doesn't need any kind of computer. But it's a great introduction to trying to understand a range of problems that we think are interesting to solve from a quantum computation point of view. Okay, so let's take a look at the problem as we've described it here. So we have 5 children, Adam, Beth, Carol, Dan, and Emma. They're invited to a birthday party. Each child wore a different colored t-shirt. The colors were green, orange, pink, red, and yellow. And after the party, they each got to take a balloon home with them. The balloons were also colored green, orange, pink, red, and yellow. And so we have a number of clues to our puzzle. Here are the clues. Each child makes sure that they took a balloon that was different to the color of their t-shirt. Adam took the yellow balloon, Carol's balloon was red, Emma loves her orange balloon, the green balloon was taken by Dan and is the same color as Adam's t-shirt. The child wearing the yellow t-shirt owns a balloon which is the same color as Beth's t-shirt. And finally, Carol's pink t-shirt has a bow on it. So the question we're asked to answer, the questions are, who was wearing the red t-shirt and who got the pink balloon? Now, as I said at the intro, this is a relatively simple problem. You could solve it with pen and paper, and indeed that's how this puzzle was designed to be solved. But it introduces a lot of the core ideas that we're going to explore around solving optimization problems and constraint problems with a quantum computer. So this is an example of what's known as a Boolean Satisfiability Problem, or a SAT problem. And other well-known examples that you may be familiar with include Sudoku, if you're a puzzle fan. But in fact, these arise all the time in industry. They're used to solve scheduling problems and many other types of problems. So very, very applicable and certainly much more difficult than the one we have here. So with all problems, usually the first place to start is to figure out, well, how do we structure the problem in a way that we can actually attack it with a computer? So let's go ahead and consider that. So here we're going to set the problem up as a 5 by 5 by 5 array. This is known in mathematics as a tensor. And along the axes of this array, we're going to put the children on one axis, the t-shirts, the colors of the t-shirts, and the colors of the balloon along their own axis. And so here what we're going to say is that a 1 in a particular cell, ijk, indicates that child I is wearing t-shirt j and has balloon k. So if we look at my poorly drawn diagrams here, for example, this looks a little bit like a kind of a 5-wide Rubik's Cube. But the idea here is that we're putting children along one axis. So child Adam, Beth, Carol, Dan, and Emma, A, B, C, D, E. And then we have our t-shirts along another axis, green, orange, pink, red, and yellow, and our balloons along a third axis, also green, orange, pink, red, yellow. And then if we look at the right here, we can see that we have a particular assignment. We've put a 1 in this entry in the array and zeros everywhere else. So the 1 tells us that in this particular assignment, child Dan has the orange t-shirt and the yellow balloon. Now, we don't know yet whether that's a valid assignment, whether that will help us to solve the problem, but that's at least how to interpret how we're going to represent potential solutions or candidate solutions. So that's it for this episode. This hopefully at least sets up the problem. What we're going to look at in the next episode is how do we write the code to express all of the puzzle clues that we've been given in such a way that we can then start to solve the puzzle. So please do join me in the next episode where we'll go deeper on this. Thank you.